In the world of heavy tractors, power has always meant more than just numbers. By the time the 1980s arrived, farmers were asking more from their machines: bigger fields, deeper implements, and longer days. Engine strength wasn't a luxury, it was a requirement, and only a few engines could keep up with those demands. Here are the 12 most powerful tractor engines ever built. Number 12, Volvo Penta TWD1683VE. By the early 2020s, Volvo Penta had already built more than a century of experience in industrial and marine engines. Founded in Sweden in the early 1900s, the company earned its reputation through engines built to handle extreme environments. That background shaped the TWD1683VE, a modern engine developed not for marketing appeal, but for demanding high-load performance in farming, forestry, and construction. Its foundation begins with displacement. The TWD1683VE is a six-cylinder diesel with a total displacement of 16.1 liters, equal to 983 cubic inches. This volume provides the breathing capacity needed for steady, sustained torque delivery across long work cycles. That capability shows clearly in its performance numbers. The engine produces up to 775 horsepower at 1,900 revolutions per minute, along with 2,510 pound-feet of torque. This torque is available early and remains consistent, which allows machines to hold ground under pressure without fluctuating output. Supporting that performance is a structure built around strength. The cast iron block provides rigidity, while steel pistons and reinforced liners handle pressure and heat with margin to spare. Maintenance requirements remain practical. Wet sleeve construction allows for in-frame servicing, and oil change intervals extend to 1,000 hours, reducing downtime over the course of a season. To make sure the engine responds smoothly under varying load conditions, Volvo Penta equipped it with a high-pressure common rail fuel system. This electronically controlled system times injection precisely, improving combustion quality and fuel efficiency without adding complexity to the operator's tasks. An additional strength is acoustic control. The engine's design incorporates noise-dampening strategies that significantly reduce in-cab sound levels. That means less operator fatigue during long shifts and less mechanical stress on surrounding components. From the structure of the block to the quiet confidence of its operation, every part of this engine points to a clear goal: deliver reliable, consistent power under serious strain. Volvo Penta's long-standing approach to building for endurance is evident here. This is not an engine designed for light tasks or short cycles. It is meant to carry weight, hold pressure, and remain ready for the next field without asking for rest. Number 11, MAN D254 2MT EV12. When MAN first entered the diesel engine sector in the early 20th century, it focused on commercial and marine propulsion. Over time, its portfolio expanded to include heavy-duty industrial engines engineered for endurance. By the time the D2542M TEV12 was introduced, the company had already earned a reputation for delivering large displacement engines capable of sustained performance under extreme conditions. This engine was built for that purpose. Featuring a 12-cylinder V layout, it carries a displacement of 21.9 liters, which equals 1,336 cubic inches. The scale of this engine allows it to maintain pressure and torque without relying on high revs, a key requirement in environments where slow, consistent pull is more valuable than top speed. That power is not theoretical. Output reaches up to 1,200 horsepower, supported by twin turbochargers that maintain airflow and boost efficiency under heavy loads. The engine delivers more than 3,000 pound-feet of torque and does so with minimal lag. This immediate torque response ensures steady traction across deep tillage, hauling, and other high drawbar applications. Supporting that output is a fuel system built around precision. High-pressure common rail injection allows the engine to regulate combustion with accuracy, keeping power delivery smooth even as load conditions fluctuate. The system also supports fuel efficiency, keeping operational costs within range for such a large unit. Durability is addressed through material choice and structural design. A thick cast iron block provides rigidity, while each cylinder is equipped with a replaceable wet liner, allowing targeted repairs without removing the engine. Internals, including pistons, rods, and crankshaft, are overbuilt to handle prolonged heat and mechanical stress. The entire assembly was designed for multi-shift operation with minimal unplanned downtime. Shifting from structure to real-world use, the D2542 MTE balances strength with refinement. Despite its size, engine balance is well maintained, with 12 cylinders firing in sequence. vibration is minimized, and operation remains steady. This not only improves comfort for the operator, but also reduces strain on the chassis and driveline components of the host machine. Fuel consumption reflects its category. Under full load, the engine burns approximately 45 gallons of diesel per hour. While substantial, that figure is consistent for its class and reflects the energy required to support such high-output, continuous workload. Over the years, the Mahan D2542 MTEV12 represents the kind of engineering built around a clear goal: sustained power without compromise. It does not operate in short bursts or light-duty rolls. It was made for equipment that works long hours, in hard soil, with no margin for failure, and it was built to meet that challenge without pause. Number 10. Mercedes-Benz OM473. While MAN was refining engines for industrial ground applications, Mercedes-Benz was perfecting diesel propulsion for the highway. The OM473 began its service life in long-haul trucks, where it was engineered for non-stop performance across steep grades, high payloads, thousands of uninterrupted hours. Its entry into agriculture brought those same principles of endurance and control to a different kind of heavy-duty work, one that demanded torque, efficiency, and staying power across unpaved, uneven ground. The transition from highway to field was not accidental. The engine's core configuration, a straight six layout with a displacement of 15.6 liters or 952 cubic inches, proved to be highly adaptable. Originally tuned for freight and logistics, its ability to deliver torque at low RPMs made it a strong candidate for tractors handling draft-intensive work like tillage, transport, and slope climbs. Torque output measures up to 2,250 pound-feet, delivered in a controlled and sustained curve. That figure is significant, not only in volume, but in its application. It arrives early, maintains pressure through load changes, and minimizes power loss across gear transitions. For agricultural use, this consistent delivery translates to fewer downshifts, better traction, and reduced operator fatigue. Complementing the torque is a peak power rating near 625 horsepower. More importantly, that power is accessible and refined due to the engine's asymmetric turbocharging system. This design manages airflow through variable pressure routes, optimizing response under varying load conditions. The result is not raw aggression, but measured force that remains stable hour after hour. Fuel delivery is handled by the X-Pulse injection system. Unlike conventional high-pressure systems, X-Pulse controls injection timing and volume with precision across all 6 cylinders. This level of regulation ensures complete combustion, improving thermal efficiency and keeping fuel consumption proportional to demand. At full load, the engine consumes approximately 48 gallons of diesel per hour, an expected figure given the output and weight classes it serves. Beyond power and consumption, the OM473 was also engineered for operator experience. Internal balancing and engine dampening reduce vibration, and combustion noise is kept within tolerable levels for long working days. The structure allows the engine to run smoothly and quietly, an advantage in machines that may operate continuously across multiple shifts. This engine was not designed for short cycles or light-duty tasks. It was designed to endure. In tractors operating across large acreages, through dense soil, and under mechanical stress, it brings a level of control that is both measurable and repeatable. The Mercedes-Benz OM473 does not need new conditions to prove itself. It has already been tested on the road, in the field, and under pressure, and it continues to perform without hesitation. Think these engines were wild? The next ones go even harder. Bigger displacement, meaner designs, and torque that could move mountains. Like the video, subscribe to the channel, and stick around. We're just getting started. Number 9. Cummins KTA1150. During the late 20th century, as horsepower demands increased across large-scale agriculture, Cummins became a leading name for delivering reliable, high-displacement engines. The KTA1150 emerged from that era as a benchmark in mechanical strength and torque delivery. It was engineered for situations where equipment size, field demands, and operating hours pushed beyond the limits of ordinary power plants. This engine was a turbocharged and aftercooled straight-six diesel with a total displacement of 18.8 liters or 1,150 cubic inches. That scale alone positioned it well beyond mid-duty categories, intended instead for deep tillage, heavy drawbar loads, and extended shift cycles with minimal performance loss. Its rated power output stood at 470 horsepower, which was substantial by the standards of the time. More significant, however, was its torque, approximately 1,570 pound-feet, delivered at just 1,500 revolutions per minute. This low-end torque made it especially effective in the versatile 1156 and other high-capacity machines, allowing consistent field speeds under heavy resistance. Performance gains were supported by the combination of turbocharging and aftercooling. Compressed intake air was cooled before combustion, increasing oxygen density and improving fuel efficiency. That system enabled smoother combustion cycles, maintained output under varying loads, and contributed to the engine's long-term reliability in field operations. Durability was another known strength. The cast iron block, forged crankshaft, and robust pistons were built for continuous thermal and mechanical stress. With wide service access and support from Cummins, the engine was also regarded as highly maintainable. Operators could perform scheduled service and major overhauls with limited disruption, often reusing the same engine across seasons or even machines. Fuel capacity and consumption aligned with its scale. The paired tractors often carried tanks around 400 gallons, allowing the engine to operate for extended hours without interruption. When kept within its torque band, the KTA1150 returned consistent efficiency despite its size. Cooling was also carefully managed. With a system capacity exceeding 80 liters, overheating under continuous strain was rarely a concern. Thermal balance was one of the key reasons why the engine could perform across varied conditions without faltering. The Cummins KTA1150 stands out not through innovation alone, but through execution. It met the practical demands of large-scale farming with mechanical certainty, providing the torque, structure, and dependability that defined a generation of high-powered tractors. Number 8. FPT Cursor 13. Long before it reached the fields, the Cursor series had already proven its strength in commercial trucking across Europe. Developed by Fiat Powertrain Technologies, the Cursor 13 was designed to provide consistent, heavy-duty output with a modern, modular approach. As agriculture shifted toward higher horsepower machines, this engine transitioned from highway to harvest without needing to change its core design. It was already built to handle load, distance, and long operating hours. This is a straight-six diesel engine with a displacement of 12.9 liters, equal to 788 cubic inches. From that compact structure comes a serious level of performance. Output peaks near 600 horsepower, and torque reaches as high as 2,050 pound-feet. What gives it field-ready capability is how early that torque arrives. Rather than waiting for high revs, it delivers force low in the speed range, exactly where tractors require strength the most. That delivery is kept consistent through precise control systems. A high-pressure common rail fuel system manages injection timing with accuracy, ensuring full combustion and stable operation under stress. Supporting that is an electronic variable geometry turbocharger, which adjusts airflow based on load and speed. These systems prevent torque dips, helping the engine hold traction even through variable soil conditions or steep inclines. The engine's fuel profile reflects modern efficiency targets. At full load, it consumes approximately 46 gallons of diesel per hour. While the figure is large, the energy output it delivers makes the trade worthwhile. Under partial loads or transport cycles, fuel use falls noticeably, contributing to long-term operational savings for machines used across multiple tasks. Its mechanical structure also contributes to long-term value. FPT minimized the number of moving parts to reduce friction and mechanical wear. Oil change intervals extend to 600 hours, and the block is reinforced to prevent distortion under repeated high-load use. These features extend service life and simplify scheduled maintenance. Beyond technical output, operator experience was also considered. The straight-six configuration provides balanced firing, reducing vibration through the frame. Meanwhile, the fuel injection system and turbo tuning limit engine noise, without sacrificing power. What distinguishes the FPT Cursor 13 is how it combines current generation technology with real-world simplicity. It does not overcomplicate power delivery, and it does not compromise torque for fuel targets. Instead, it holds both together firmly. That ability to work hard, adapt fast, and hold strong under pressure makes it one of the most respected engines in the field today. Number 7. ADE 444 TIV12. The ADE 444 TIV12 did not emerge from global manufacturing giants. It was built in South Africa during a time when the country needed homegrown machines that could survive tough terrain and long hours. Designed and produced by Atlantis diesel engines, it was more than just a power plant. It became a symbol of mechanical independence, developed to meet agricultural and military needs without compromise. this engine stood out from the beginning. A V12 diesel with 12 working cylinders and a total displacement of 22.0 liters, or 1,342 cubic inches, it quickly earned a reputation as one of the largest engines ever installed in a production tractor. That alone placed it in a unique category. But size alone does not explain its performance. What mattered was how that size was used. Depending on tuning and configuration, the ADE 444 Ti V12 produced between 450 and 600 horsepower. In field terms, that kind of output meant serious pulling strength. Whether it was mounted in tractors like the Big Bull or fitted into military vehicles, the engine responded with force that could pull heavy rippers, tillage equipment, and loaded trailers across varied terrain without hesitation. Low-end torque was one of its most valuable traits. The engine developed power early in the rev range, allowing machines to move forward with confidence even under extreme loads. When operating in muddy fields or pulling against resistance, it held its pace without requiring high engine speeds. That gave operators both control and productivity in conditions where lighter engines struggled. To manage that performance, the engine was equipped with a turbocharger and an intercooler. These systems worked together to improve airflow and control engine temperature, even during long workdays in high heat. The result was not just more power, it was power that stayed consistent hour after hour. Reliability was central to the engine's design. Atlantis diesel engines prioritized simplicity and serviceability. The engine block was made from high-strength material with thick walls and wide cylinder spacing. Components were built for endurance rather than compactness, which made field repairs more accessible. There were no digital systems or fragile sensors, only strong mechanical parts designed to run in remote areas with limited maintenance support. Fuel usage was high, as expected from an engine this size, but it was not wasteful. When kept in its optimal operating range, the 444 Ti delivered work for every gallon it consumed. Operators who understood its rhythm reported efficient, steady output, especially during full-load operations where smaller engines would fall behind. The sound of the ADE 444 Ti V12 left a lasting impression. Deep and heavy, the engine turned slowly and confidently. It did not need speed to get noticed. It only needed traction, load, and time. This engine holds its place not because of modern features, but because of the strength, endurance, and mechanical honesty it brought to the field. Number 6. Cat C18 ACERT. It's that Caterpillar has long held a reputation for building engines that dominate the hardest jobs in mining, construction, and agriculture. With decades of experience designing heavy-duty diesel power plants, their approach has always centered on combining strength with endurance. That legacy is what led to the development of the Cat C18 ACERT, an engine built not just to perform, but to outlast. The Cat C18 ACERT is a straight-six, four-stroke diesel engine with a displacement of 18.1 liters, which equals 1,104 cubic inches. This makes it one of the largest inline six-cylinder engines Caterpillar has placed in field-ready machines. Its scale alone places it in a high-performance class, but its true strength lies in how it puts that size to use. Depending on configuration and application, the engine produces between 575 and 700 horsepower, along with torque outputs reaching 2,592 pound-feet. That level of force is not just theoretical, it translates directly into real-world pulling power. Tractors equipped with the C18 can handle oversized implements, long field passes, and heavy-duty transport tasks without faltering. Supporting that output is Caterpillar's ACERT technology. This system enhances engine breathing through a combination of electronic fuel management and advanced turbocharging. Air is carefully compressed, cooled through an aftercooler, and then delivered to the cylinders at ideal pressure. When matched with finely timed fuel injection, the combustion process becomes more efficient and powerful across the entire operating range. That precision contributes to a major strength of this engine: consistency. Whether under full strain or moderate workloads, the Cat C18 delivers steady power without irregular spikes or drop-offs. For field operators, that means fewer gear changes, better traction, and more predictable handling across uneven ground or varying soil conditions. Durability is another area where the C18 excels. The engine block is reinforced for long-term structural integrity. Components like the crankshaft and connecting rods are engineered to withstand high thermal and mechanical stress. The cooling system is designed for endurance, maintaining thermal stability even in dust, heat, and prolonged field exposure. Fuel consumption at full capacity sits around 50 gallons per hour. While that is significant, it aligns with expectations for an engine of this class and output. More importantly, its combustion efficiency allows for improved economy during lighter-duty work. Service intervals can reach up to 500 hours, reducing overall maintenance downtime. Noise and vibration control also contribute to the engine's appeal. Despite its size, the C18 runs smoothly. Operators experience reduced cabin noise and lower fatigue over long shifts, improving both safety and productivity. The C18 ACERT is not built for light duty, it is built for leadership. It handles extreme loads, adapts intelligently to changing demands, and maintains power delivery without compromise. Number 5. John Deere PowerTech 13.5 liters. John Deere's reputation in agricultural power is not built on flash or size alone. It is built on trust on engines that start early, work late, and rarely need an excuse to keep going. The PowerTech 13.5-liter diesel is one such machine. It does not shout about its presence. It proves itself where it matters, in the field, under full load, day after day. At the center of this engine is a 6-cylinder inline diesel configuration, with a total displacement of 13.5 liters, or approximately 823 cubic inches. While not the largest in this lineup, it earns its spot by offering exceptional real-world power, dependable torque, and the kind of mechanical endurance that farmers come to rely on. Depending on how it is configured, this engine delivers between 400 and 625 horsepower. That strength is backed by torque numbers that approach 2,000 pound-feet, giving tractors the ability to manage large implements, press through difficult terrain, and maintain forward momentum even under heavy strain. The technology inside the PowerTech platform ensures that power is not only strong, but also controlled. It features high-pressure common rail fuel injection and a variable geometry turbocharger. These systems work together to provide precise fuel delivery and adaptive air management. As a result, the engine maintains consistent performance during turns, hills, and sudden load changes without loss of efficiency or responsiveness. This steady delivery of force is matched by a design that values longevity. The engine block is made of reinforced cast material, built to withstand long-term stress. Internals like pistons, connecting rods, and the crankshaft are engineered for high-duty cycles. Combined with an advanced cooling system, these features allow the engine to operate under extreme temperature and load conditions without compromising structural integrity. Efficiency is another defining trait. Under full load, fuel consumption reaches around 48 gallons per hour, which remains reasonable for the output class. During lighter operations, the engine demonstrates even greater economy. Service intervals can extend to 500 hours, allowing more time in the field and less time in the shop. Noise and vibration levels are also notably low. The 6-cylinder layout, along with smart injection control, allows the engine to operate quietly and smoothly. This improves operator comfort, reduces wear on surrounding parts, and makes the entire machine feel more refined in motion. The John Deere PowerTech 13.5 does not rely on extreme size or overbuilt features to prove its worth. Instead, it represents balance with serious pulling power, long-term durability, and intelligent design all working together. Number 4. Cummins QSX15. In the world of agricultural power, few names carry as much weight as Cummins, and among their lineup, the QSX15 stands out not just for its size, but for the way it delivers power, efficiency, and strength in one complete package. This engine was built to handle more than just heavy jobs. It was built to dominate them. This engine is a straight 6-cylinder diesel with a displacement of 15.0 liters, which equals approximately 915 cubic inches. That makes it one of the largest inline-6 engines Cummins has ever developed for off-road equipment. Its size alone places it in a higher category of working machine tractors that must pull vast implements, operate in difficult terrain, and stay in motion for hours without interruption. Performance figures speak to that purpose. The QSX15 produces up to 675 horsepower, while torque exceeds 2,050 pound-feet. This level of torque arrives early in the power band, allowing tractors to operate efficiently at lower engine speeds. And that translates into better traction, less fuel waste, and more consistent delivery of force across changing field conditions. Supporting this performance is a suite of advanced systems. The QSX15 utilizes a high-pressure fuel injection system that ensures clean and complete combustion. A variable geometry turbocharger provides precise airflow adjustment, while cooled exhaust gas recirculation helps stabilize cylinder temperatures and reduce emissions. These features work together to keep the engine running strong under full load, even during back-to-back work cycle. Fuel economy was carefully considered during its development. Under maximum load, the engine burns around 50 gallons of diesel per hour. However, because of its high low-end torque and intelligent air-fuel balance, it performs efficiently during mid-range work or transport. This ability to scale fuel use based on workload gives the engine a practical edge in real-world operations. Cummins also ensured the QSX15 could meet strict environmental regulations without sacrificing power. It includes a diesel particulate filter and a selective catalytic reduction system. Both are integrated with a self-cleaning regeneration cycle that operates while the machine is in motion, eliminating the need for downtime. Durability was built in from the start. The engine block is cast from high-strength materials, and every internal component from the pistons to the crankshaft is designed to withstand high pressure, temperature, and long service hours. Maintenance intervals stretch up to 500 hours, and the layout allows for fast access to key components. The QSX15 stands out not simply because of its raw power, but because of how reliably it delivers that power day after day. Number 3. Detroit Diesel 12V92. In the late 1960s and early 70s, as demands for industrial power grew, Detroit Diesel answered with one of the boldest engineering moves of its era. The result was the Detroit Diesel 12V92, a two-stroke V12 engine that became a benchmark in the world of heavy-duty machines. Originally built for military, marine, and heavy transportation sectors, this engine soon found a home in large tractors, where raw pulling force was a necessity, not a luxury. This engine featured two banks of 6 cylinders arranged in a V shape, each with a displacement of 12.1 liters, giving a total displacement of 24.2 liters, or approximately 1,475 cubic inches. This level of displacement placed it among the largest diesel engines used in off-road and agricultural settings. Its physical size was substantial, but its output was even more impressive. Depending on tuning and configuration, the 12V92 produced between 450 and over 700 horsepower. Torque ratings exceeded 2,000 pound-feet, making it suitable for the most demanding field operations. Its two-stroke cycle design allowed every cylinder to fire on each revolution, delivering immediate torque and a fast throttle response. There was no hesitation. Power arrived the moment it was needed. This aggressive torque delivery made the engine particularly effective in deep soil tillage, heavy trailer pulling, and steep terrain. Even at low revolutions, it did not lose momentum. Instead, it dug in and kept moving, no matter how challenging the load. That capability earned it respect from farmers, contractors, and military operators alike. Besides this, turbocharging also played a central role in its performance. The 12V92 featured twin turbochargers supported by a Roots-type blower. This system ensured rapid and dense airflow into the cylinders, boosting combustion efficiency and maximizing power with every stroke. It was a mechanical solution built for continuous heavy-duty use. Structurally, the engine was built to endure. It used a robust cast-iron block, high-strength cylinder liners, and heavy-duty internals capable of resisting extreme heat and pressure. These features allowed it to run for extended hours in harsh environments without mechanical fatigue. From Arctic deployments to remote farmlands, the engine proved itself through relentless service. Fuel use was high, especially under full working load, but so was output. For operators who needed unbroken pulling strength, the trade-off was worthwhile. This engine was not designed for efficiency at idle. It was made to move heavy machines through difficult terrain and deliver results. Its distinct sound, a low, thunderous growl, became an audible symbol of power. Decades later, the 12V92 remains in service in various corners of the world, a testament to its durability and raw capability. The Detroit Diesel 12592 is more than an engine. It is a legacy of engineering built to work, to endure, and to dominate. Number 2, JD18X. In recent years, as agricultural machinery has grown larger and more demanding, John Deere responded with a bold and powerful solution, the JD18X. Introduced as the most powerful engine the company has ever produced, it marked a major turning point in Deere's commitment to meeting the horsepower needs of the modern farming era. This engine was not designed for average fields or ordinary workloads. It was engineered for operations that demand consistent, heavy-duty performance over long hours and under punishing conditions. At the center of the JD18X is a straight six-cylinder diesel engine with an immense displacement of 18.0 liters, equal to approximately 1,098 cubic inches. This places it at the top of John Deere's engine lineup in terms of size, and more importantly, torque output. The engine's physical footprint is massive, but every inch of it serves a purpose: to deliver sustained force and intelligent power distribution across large implements and variable terrain. Rated for up to 675 horsepower, the JD18X also generates a peak torque of 2,650 pound-feet. This level of output provides unmatched traction force, making it ideal for wide cultivators, heavy grain carts, and steep inclines, where engine responsiveness cannot lag. The torque curve remains flat through a wide range, ensuring that power stays consistent even during demanding field operations. Yet power alone is not what elevates this engine. Its real strength lies in its intelligent integration of advanced systems. The JD18X is equipped with dual turbochargers, a high-pressure common rail fuel system, and next-generation electronic control units. These systems monitor operating conditions in real time and adjust fuel delivery and airflow for maximum efficiency. Even under full stress, the engine maintains smooth operation with minimal waste and controlled emissions. Fuel consumption is proportional to its capability. Under peak load, it may consume around 50 gallons of diesel per hour. However, in partial load scenarios, such as transport or light tillage, the system adapts and significantly reduces fuel draw, maintaining both economy and output. Durability has not been compromised in pursuit of innovation. The engine uses reinforced cast iron construction, pressure-resistant liners, and a high-capacity cooling system. Service intervals are extended with oil changes reaching up to 500 hours, reducing downtime across critical farming periods. This makes it a practical choice for operations where every hour of productivity counts. Despite its size, the JD18X operates with surprising refinement. It produces minimal vibration, and its acoustic profile is quieter than many smaller engines. For the operator, this results in less fatigue, better control, and a more stable ride across challenging terrain. Built for machines that must perform without interruption, the JD18X proves that modern power is not only about scale, it is about how wisely that power is applied and how long it lasts under pressure. Number 1. Detroit Diesel 16 FE92. The Detroit Diesel 16 FE92 was developed during a time when engines were expected to perform without compromise across military, industrial, and emergency applications. It was originally designed in the 1970s as part of the larger Detroit 92 series, and its capabilities quickly placed it among the most powerful two-stroke diesels of its era. When repurposed for agricultural machines, its performance changed what tractors could achieve in the field. This is a two-stroke V16 diesel engine with a displacement of 24.1 liters, which equals about 1,470 cubic inches. The engine used twin banks of 8 cylinders each, firing alternately with remarkable force and rhythm. Its basic design prioritized high-output performance in confined spaces, making it ideal for large tractors requiring compact strength. Depending on the specific calibration, the engine delivered over 800 horsepower, and torque could reach close to 2,500 pound-feet. The two-stroke layout gave it a key operational advantage. Each cylinder produced a power stroke on every revolution, allowing for faster torque delivery and improved acceleration under load. Air management played a significant role in the engine's success. It used both a turbocharger and a roots blower. This dual setup ensured constant airflow into the cylinders, which improved combustion and helped maintain power under stress. Unlike naturally aspirated engines that would struggle at higher altitudes or during high-resistance tasks, the 16 FE92 kept delivering consistent output across all conditions. Its construction reflected the demands of continuous service. With a reinforced cast iron block, replaceable wetliners, and hardened internals, the engine was built to absorb vibration and resist heat expansion over long hours. Farmers who used it in high-horsepower tractors reported minimal loss in performance, even after years of work in extreme field conditions. Fuel consumption was substantial, especially under full throttle. The engine could burn more than 60 gallons per hour in certain applications. However, when matched with heavy-duty implements, it often completed tasks more quickly than smaller engines, offsetting fuel costs through reduced operating hours. Another notable feature was its unmistakable sound. The synchronized pattern of 16 cylinders in a two-stroke cycle created a deep, steady growl. It became instantly recognizable on farms and construction sites alike, signaling that a high-output machine was in operation. The Detroit Diesel 16592 was not designed for efficiency alone. Its presence in agriculture proved that an engine originally built for defense and emergency response could set the benchmark for tractor performance. Whether it was torque, toughness, or total dominance, these tractor engines proved they were built differently. Hit like if one of these beasts still runs on your farm, and drop a comment if we left out your favorite. More diesel greatness coming your way, so subscribe and stay tuned.